and that lens can focus the light. So if you see a bright spot of light, it will also become a very bright spot inside your retina. And if you have only one color, that spot can become very small inside your retina. Yes, so with laser light we have to be extra careful because it can hurt our eyes. We have always two types of reflection. One is called specular reflection, like in a mirror. So the light keeps going and reflects in straight light. And another is diffuse reflection. You see only the photos that come straight into your eye. The aperture of your eyes, your pupils, is about this big. Yeah. So if I have one photon, it goes in this direction, second one in this, third one in that. They are all going over an angle that is 180 degrees in all directions. And the photons you are collecting in your eyes are just a very tiny piece. Imagine how many photons are going straight in that direction. There's too many. And at that point, when there are so many, it can hurt your eyes. You have seen it, or maybe you have done it. Go out on a hot day and you get the sun, you put a magnifying lens, and then you can burn a piece of paper. That shows you that light has energy and it can heat up and it can cause damage. That laser spot could be many, many times more intense than sunlight. So you cannot see it directly looking at the source, looking at the laser. That's why I have these two polarizers. If the polarizers are crossed, the intensity is zero. If the polarizers are parallel, the laser is very intense. And I'm using an intensity in the middle. Yes, so I can work comfortable and safe, and I can still see what I want to see. Yeah.
This experiment is about diffraction. There is a principle saying that the diffraction pattern of an obstacle is the same as the diffraction pattern of an aperture of the same shape.
Secondary maxima, where the light is, it means that light is getting constructive interference in every bright spot. If I change the slit to the next one, that is a little bit smaller, and you see that the separation between the beams becomes larger.
The constructive interference.
Here I have the model of the DNA. This is spring. What you will see is that every part of the spring will act as an obstacle and will create a diffraction pattern. You will see two of these diffraction patterns. Before we only see one. Let me do one thing before I change.
We have used a spring to represent the DNA shape. In the other experiment that uses X-ray rather than laser beam. With the laser light, we can easily see the diffraction that goes through the spring and giving out the effects and being optimized on the screen. We have used a mirror to double up the distance between the spring and the screen. With the mirror and the longer distance and the larger image we see, we can easily find out the diffraction, and it helps us to measure the diameter of the spring. When the laser lights hit on the spring, we can see the diffraction on the screen easily. This experiment can help us to know more about diffraction and also giving us some new insights from it. With the more science techniques and the knowledge we know, it can really help us to enhance our knowledge and also give us some new experience on art and science combinations. It helps us on creating artworks and also know more about the world. Thank you.